because when the fluid is at rest, here it doesn't contain any tangential force. So therefore the force exerted, or the total pressure force exerted, will be normal to the surface. So therefore the normal force exerted by the fluid at rest on the surfaces, which is either plane or curved, with which it is in contact, is known as hydrostatic pressure force. So here, since it doesn't have the tangential components, when the fluid is at rest, the total pressure force will act normal to the surface. This total pressure force is expressed in newtons, that is in SI units. And also we should find out where this pressure force will be acting, or at what point it is acting. So therefore the point of application of the total pressure force is known as center of pressure. So now shall we take one by one derivation, in which I am taking only plane surface. First I will take up a horizontal surface and try to find out the total pressure force. So next I will go ahead with the plane surface, that is vertical, find out the total pressure force on the plane surface and also determine the center of pressure. Then I will take an inclined surface, then find out the total pressure force on the inclined surface and also the point of application of this total pressure force. So now consider, here we have a horizontal plane surface of area which is immersed completely in a liquid of specific weight omega. So let the distance of the CG of the plane surface. So this is the figure. So now here we have, so we have to consider a plane surface which is kept horizontally, so at a distance x bar. So the CG distance is at x bar from the free surface. This horizontal plane surface is of area A. Now here you can consider an elementary area dA. So since it is horizontal, any elementary area that you take it on the surface will be the same distance, that is x bar, from the free surface. So how to find the total pressure force? Now when you first you have to find out what is the pressure intensity on this elementary area. So pressure intensity, because pressure intensity depends upon the vertical distance of that area from the free surface. Since the vertical distance is x bar, it is omega into x bar. So here, okay, so here pressure intensity P will be equal to omega into x bar, because it is at a distance x bar. So now in order to find out the force on the area, so therefore the pressure force will be P into area, that is P into dA. So now the pressure force, we can name it as dF, so it will be P into dA. So what is P? It is omega into x bar. So therefore it is omega into x bar into dA. So now if you consider this entire area to be made up of such elementary area and try to find out the forces on each of the areas, so then sum it up, then you will get the total pressure force. Since here, so here you can consider the area to be made up of number of elementary areas. So total pressure force can be calculated by summing up all the forces dF. So therefore it is integral of dF or summation of dF. So therefore it is summation of omega x bar dA. Since specific weight is a constant, x bar is a constant, so you can write omega into x bar into integral. So what is the summation of all ds? It will be equal to the total area A. So therefore it is omega x bar into A. So what is omega x bar? It is nothing but the pressure intensity acting at the CG multiplied by the total area will give you the total pressure force. So therefore the total pressure force, which is normal to the surface, will be acting at the center of the surface, and that will be equal to the pressure. It is nothing but the product of intensity of pressure at the centroid of the area multiplied by the area of the surface. So therefore, hence remember that the total pressure force is nothing but omega A into x bar. So what is x bar? It is the distance of the CG from the free surface, vertical distance of the CG from the free surface, whereas total A is the total area of the horizontal plane surface, and omega is the specific weight of the fluid. So next will be the total pressure on a vertical plane surface, and here also we are considering a vertical plane surface of area A, which is immersed completely in a liquid of specific weight omega. So here we are required to find the distance of the CG. So for any surface we find the CG and let that distance be x bar from the free surface. So also here consider an elementary area dA at a distance x from the free surface as shown in the figure. So in this case, this complete area is immersed and the CG distance is marked as x bar. So now note here, so if you take any area, so let that distance be x. Okay, so because here if you take any other area, so the distance x goes on changing. So in the previous case, in horizontal plane surface, if you take any elementary area, it was at a distance x bar, but in this case it is not so. So in this case, the distances, as you move downwards, the distance x goes on increasing. So therefore here the variable quantity is x. So now find out the pressure. Now as usual, you consider an elementary area, find out the pressure intensity. So what is pressure intensity here? So pressure intensity is on the elementary area is omega into x. Okay, so if you multiply by the area dA, you will get the force, so that is dF. So in this case the dF goes on changing because x goes on changing. So now you consider entire area to be made up of such elementary area and find out the dF for each of these areas, and then you sum it up, you will get the total force. So this is what will be done in the derivation. So now consider an elementary area dA at a distance x. So therefore if you want to find out the pressure intensity on that elementary area, so then you have to take the vertical distance to the elementary area, which is x. So therefore it is omega into x. So therefore the pressure intensity on elementary area is P equals omega into x. So if you want to find the force, so you have to multiply by the area dA. So therefore the pressure force on the elementary area dF will be equal to P into dA, but you know that P is omega into x, so it is omega x into dA. So if you consider the entire area to be made up of such elementary areas, so you can go on finding out the forces on each of the elementary area. So please note that, so as you take the elementary areas, so the distance x it was same, so the x quantity is changing. So as you move towards here, so take here the x will go on changing, so also the force also goes on changing. So that's the reason why we have to find dF on each of the element areas and add all the forces, and so that you will get the total forces. And so therefore here, so whenever you can, if you consider the area to be made up of number of elementary areas, then you take summation of all this, okay, forces to get the total pressure forces on area A. So therefore it is summation. So when you take the integral of omega x into dA, only specific weight can be taken out of the integral because x will be a variable quantity. So therefore it is inside the integral. So now here in engineering mechanics you have studied that, so what is integral of dA into x? So dA into dA is nothing but the area multiplied by the distance, so we will get the moment. So here it is the moment of the area about which axis? About the free surface. So if you take summation, it's a summation of first moment of areas about the free surface. But in engineering mechanics you have studied that summation of first moment of area is nothing but the total area multiplied by its CG distance, that is A into x bar. So as you know, the definition of centroid is A1 x1 plus A2 x2 plus A3 x3 divided by total area. So therefore A1 x1 plus A2 x2 plus A3 should be equal to total area into x bar. So this is what is a1 plus a1 x1 plus a2 x2 plus a3, so on is nothing but summation of x into dA. So because x changes, it can be x1, for next area it can be x2, next area it can be x3, like this. As the area also, you can, if it can be a1, the next area, the distance x2 may be a2. So that is a1 plus a1 x1 plus a2 x2 is nothing but summation of first moment of area, which is nothing but total area into x bar. So that goes according to the centroid definitions that you studied in engineering mechanics. So therefore it will be omega into x bar. So whether it is a horizontal surface or a vertical surface, the pressure force is nothing but omega x bar into A. What is omega x bar? It is pressure intensity at the CG, and if you multiply by the total area, you will get the pressure force. So therefore the pressure intensity is also nothing, the total pressure force is also pressure intensity at the centroid, which is omega x bar multiplied by A. So as I told you that summation is the summation of x dA, summation of first moment of area, which is area into x bar. So therefore it is the total pressure force on the plane surface is equal to product of the intensity of pressure at the centroid and the area of the surface. So here now we are required to find out the where this pressure force is acting. Okay, so that is where this F is acting. So let this force F be act at a distance h bar. So whether it coincides with CG or it is below CG, we have to determine. So just here you can take as h bar, and we'll try to find out. So what is the distance h bar in the next derivation. Now again taking the same sketch. So now you know that if you take an elementary area, so pressure intensity is omega into x. If you multiply by the area, so you will get the total, that is the pressure force on the elementary area dF. So therefore it is the pressure force dF is P into dA, because P is omega into x, it is omega x into dA. So now you take moment of this force dF about the free surface. So that will be dF into x. So therefore the moment of dF about the free surface is nothing but dF into x. So what is dF? It is omega x into dA. So therefore it is omega x dA multiplied by x will be the moment of dF about the free surface. Now you consider the area to be made up of number of such elementary area. So now you can take the summation of all these moments of, so now if you consider number of areas like this, so you go on finding the moments of each for each of df's about the free surface. So you will get the summation here something like this. So here, since omega is a constant, you can take out of the integration sign. So now, as in the previous case, you know that dA into x is the first moment of area, but if you multiply by one more x, it will become the second moment of areas. But this integral will give you summation of second moment of areas. Where the moment is taken, the moment is taken about the free surface. So therefore you will get summation of moment of, okay, moments of all the forces about the free surface. So therefore here the summation of second moment of areas, summation of second moment of areas about the free surface. So what is summation of second moment of area? It is nothing but the moment of inertia. Since the moment is taken about the free surface, we will get moment of inertia of the plane surface about the free surface. Okay, so that can be denoted as I naught. So therefore it is omega into I naught. So this is what written. Now if we know that from principle of Wegen's theorem or from principle of moments, that is summation of moment of areas or summation of moment of force dF about the free surface is equal to moment of the resultant force about the free surface. Since here Wegen's theorem states that the moment of resultant about any axis, that is free surface, is equal to summation of its components, moments of the components about the same axis, that is the free surface. So now the component of F is nothing but dF here. So like dF1, dF2, dF3, dF4, like that, and each of the moments we have taken and made it as a summation, which is this. So therefore this term has to be equal to F into H bar. What is moment of the resultant? It is F into H bar. What is summation of moments? It is omega into I naught. So therefore from Vergnan's theorem, F into H bar can be written as omega into I naught. So taking the same figure, so now you know that what is H bar? It is omega I naught by F. But we have determined that F equals, the total pressure force should be equal to omega AX bar. So substitute and get that omega into I naught divided by omega X bar. So omega and omega cancels. So you're left with I naught by AX bar. So, but parallax theorem states that the moment of inertia about any axis should be equal to moment of inertia about the CG plus area into the distance between the CG and the free surface square. So that means here the distance between the CG and the free surface is X bar. So it has to be I naught should be equal to IG, that is moment of inertia about the CG, plus area into X bar square. So therefore by parallax theorem it is I naught equals Ig plus Ax bar. You substitute I naught in the previous equation. So therefore it is Ig plus Ax bar square divided by Ax bar. So therefore Ax bar square divided by X bar cancels out and left with X bar. So it will be X bar plus Ig by X bar. Now you know that since Ig by X bar is a positive quantity, so therefore you are adding something to X bar. So therefore H bar is always greater than X bar. Hence the center of pressure where the force F is acting, which we have taken distance as H bar, has to be always greater than the X bar. That's why the center of pressure always lies below the CG. So hence it is proved that center of pressure always lies below the CG of the plane surface. So if they ask you to find out what is the point of the location of center of pressure, then it is got by H bar is X bar plus Ig by X bar. So on the same principle, we'll also go ahead with the total pressure on inclined plane surface. So here a little bit concept is quite different, but everything, the derivation remains almost in the similar lines of the vertical plane surface. So here we are considering an inclined plane surface. So here, so the of an area A. So similarly here, so when we take an edge view, so this is the edge view. So it makes an angle theta with respect to the free surface. So if you do the edge view, if you draw a perpendicular, so then it is called as the axis OO. So all the inclined distances are measured from axis OO, whereas the vertical distances are measured from the free surface. So first thing is that you have to mark the CG and project on to the edge view. So once you project it, so this and the vertical distance will be X bar. Okay, now you consider and let that inclined distance, if it is X bar as a vertical distance, and CG distance, inclined distance from axis O will be Y bar. As I had done in the previous case, consider an elementary area, so which is you project onto the edge view. So the vertical depth is X, whereas the inclined distance is Y. So here the force dF will be acting on this elementary area. So now same thing, pressure intensity P is always depends upon the vertical depth. So therefore if you want to find pressure intensity is omega into X. So if you multiply by the area dA, then you will get the force dF. So therefore here dF is nothing but again omega X into dA. So that's what done. So now this is all I have explained. So you have to consider an elementary area dA at a vertical distance X and inclined distance Y from the axis O as shown in the now if you want to find the pressure intensity in the elementary area, it is omega into X. But here since sine theta is x by y, so therefore x will be equal to y into sine theta. So therefore substitute x as y sine theta, which will become w y into sine theta. Now if you multiply by the area, you will get the pressure force. So therefore the pressure force is omega y sine theta dA. Now if you consider this the number the area to be made up of number of such elemental areas, and find out the force of each of that. So therefore here the total pressure force on area will be nothing but summation of all the forces here. So why we have considered the inclined distance is that why we have converted this x to a distance, because the perpendicular distance for the force is always the inclined distance, not the vertical distance. So that's the reason why we have converted x to y sine theta. And similarly force we have also written in here, because this distance is taken, that is y sine theta is taken instead of x. So therefore we don't take like force is wx into dA and then integrate it. So it will be wrong, because for the perpendicular distance for df is nothing but y. So that's why we have to take in this fashion. So that's it, that is x has to be converted to y sine theta, and then take df by multiplying by the area, and then take the integral. So substitute here. So now you know that omega and sine theta are a constant, so therefore it is taken out of the integral sign. But here dA into y, so dA is the area, y is the distance, it is the first moment of area. Integral will give summation of first moment of areas, so that means a1 y1 plus a2 y2 is okay will be equal to, so what is that? It is the definition of y bar. So that is the CG distance, because here y is involved, so therefore CG distance has to be inclined. So y bar is nothing but a1 y1 plus a2 y2 plus a3 y3 divided by the total area. So what is summation of first moment of area? It will be a into y bar. So that's the reason why we have written omega a y bar sine theta. So but now you convert y bar sine theta to x bar by writing as omega ax bar. So again, whether it is horizontal surface or vertical surface or inclined surface, the total pressure force is always omega into x bar, which is pressure intensity at the CG multiplied by the total area. Okay. So here I have written here, so y bar sine theta is nothing but x bar, so the formula remains the same. So therefore the total pressure again pressure force on the plane surface is again equal to product of the intensity of pressure at the CG multiplied by the area. So as we had done in the previous case, we are required to find out the center of pressure. So what is center of pressure? The point of application of pressure force F is known as center of pressure. Let it be at a vertical distance h bar and an inclined distance be yc. So now we have to again prove that whether it coincides with CG or it will be below CG. So again the same figure, and here what is required is the moment of force is required. So therefore the pressure force in the elementary area dF is P into dA. So P into dA is nothing but omega y sine theta, because here P is nothing but omega into x, but x is nothing but y sine theta. So here it is omega y sine theta a. So now take moment of df about. So see here the distance is y not x, because the perpendicular distance to df is y. So now we are taking moment about the axis O. So therefore the moment of df about axis O will become df into y. So what is df? It is omega y sine theta dA. So multiply by y, so which becomes omega y square sine theta dA. So now take summation of, so consider the area to be made up of such element area and try to find out the forces on each of the element area and sum it up. So therefore summation of all the moments of df about axis should be integral of omega y square sine theta dA. So taking out omega sine theta, the integral of y square dA. But here dA into y is first moment of area, multiplied by y is second moment of area. So it is summation of second moment of areas. About which axis? It is about axis O. So therefore we will get moment of inertia of the plane surface about axis O, because the moments are taken about the axis O. So therefore it has to become W sin theta I naught, where I naught is nothing but the summation of second moment of areas about axis O, so which is integral of y square dA. So therefore it is nothing but, as we have studied in the engineering mechanics, that it should be I naught. What is I naught? Why we say I naught? Because it is axis O or IO. Okay, instead of we tell is I naught, because it's not about the free surface, it is about the axis O. So now from the principle of moments, you know that summation of all the moments, that is the summation of moments of df about axis O is equal to the force into distance. So what is resultant force into distance? Because Bernoulli's theorem states that moment of resultant F, that is about axis O, should be equal to summation of all the elementary areas, the summation of moment of df of the elementary areas about the axis O. So therefore F into, it is not h bar, it is F into yc, should be equal to W sin theta I naught, because it is summation of the moments. So again writing this, now I want the distance yc, so therefore yc is omega sin theta I naught by f. But you have already studied that f is equal to omega ax bar, or already derived, so substitute. So omega omega cancels, we are left with I naught sin theta by x bar. Okay, so now you know that here this x bar is nothing but y bar sin theta, because I want all the inclined distances. So sin theta gets cancelled out here, therefore you're left with I naught by ay bar. Now you can apply parallaxes theorem. So what is parallaxes theorem? The moment of inertia about any axis, here axis is O, I naught, so therefore we have to move parallelly. So therefore moment of inertia about the CG plus area into distance. Distance between the CG and axis O is y bar. So it will be y bar square. So therefore by parallaxes theorem, it is I naught equals Ig by ay bar square. So substitute in the equation yc. So therefore ay bar and this cancels out, and you are left with y bar plus Ig by ay bar. So, but you know that your sine theta is nothing but uh, x bar by y bar. Sine theta is also h bar by yc. So therefore, wherever we have yc, we can substitute as h bar by sine theta. Wherever a y bar is there, we can substitute as x bar by sine theta. So therefore, yc can be written as h bar by sine theta. Y bar can be written as x bar by sine theta. Ig can be written Ig by divided by A. Y bar can be written as x bar by sin theta. So sin theta goes to the numerator. Multiplying by sin theta throughout, we'll get h bar should be equal to x bar plus Ig sin square theta by x bar. So here, if theta is equal to 90 degree, then this becomes the vertical surface. And if theta is equal to 0, so then it will become, okay, it will become the horizontal surface. So like this, you will be able, this is a general formula. Here moment of inertia have to be very careful. So while it is Ig is moment of inertia of the plane surface, which is about the CG, and h bar is the vertical distances. If you want, you knowing h bar and theta, you can also find out yc, or yc can be determined by I naught by ay bar. So here also Ig sin square theta by x bar is a positive quantity, so therefore h bar is always greater than x bar. Hence in the inclined surface also, center of pressure is always below the CG. So that's about the derivations part. So with these concepts, you should be able to solve the number of problems which are related to the plane surface. In the lecture number 6, I'll be going ahead with number of problems that could be solved for vertical surface, as